Let's go.
We got that Coca-Cola bottle, shake, shake, shake. We got that sugar, do you want?
So we already know that this is a rational function. So therefore, this part cannot be 0 because this is the restriction for rational functions. So after getting the value of x, we have that x cannot be minus or plus 1. So we can see that our domain is all real numbers or minus infinity to infinity except minus 1 and 1. Also, with this, we can immediately find the vertical asymptotes that happen to be where x equals minus 1 or plus 1. The x-intercepts, well, we only have to make the function equal to 0 and then algebraically get the value of x, which give us x is equal to plus minus 2. So in here we have our x-intercept. To get the y-intercepts, well, we only have to set the function to f of 0, it's equal to 0 squared minus 4 over 0 squared minus 1, and we get our result, which is 4. Therefore, our x-intercept is 0, 4.
In order to get the horizontal asymptote, we have to set the limit to plus infinite and also our limit to minus infinite. And doing that, we're gonna get our horizontal asymptote.
So, in order to check the symmetry of my function, well, first I have to set f of minus x. Therefore, all of my x's become minus x. And when I solve for it, I take a look and I found out that this function is the same as my original function. Therefore, the symmetry is even.
For this equation, as we can see, we can apply the quotient rule like this, and with the multiplications we can simplify these terms and get our final answer.
That's the first derivative of our function.
Want it, andale, you know we got it. That's why we say, oh, Latina, baby.
After getting our critical points, well, we have to set this chart along with our critical points that are our asymptotes in this one over here. Therefore, we have to substitute with values in between, and we only have to write the sign over here. And when it is a minus, it means that the function is decreasing, and when it is a plus, it means that the function is increasing. Therefore, our maximum is infinite and our minimum is 0, 4. And here our increasing and decreasing ranges, which means from where to where is increasing and from where to where is decreasing. Well, to get the second derivative, first we have to set the first derivative. Then we can see in here that, well, this is a quotient rule and also a chain rule. So we set it as a quotient rule, and then we solve the quotient rule along with the chain rule, and we have to multiply the terms and add and subtract the ones that are similar. And here we can see that, well, the sign was changed, so we had to take it out from here up to here. So we got that our second derivative is this one.
This time we have to get our inflection points, but from our second derivative, and then we can start with the concavity test as follows.
We only make our chart like this with our asymptotes over here, and well, again, like in the previous test, we have to check out the values that in this case on the second derivative. If we get a minus, it means that it's going downward. If we get a plus, it means that it is going upward. Therefore, we have here that, well, that the concavity is going down from minus infinity up until minus 1, and then from 1 until infinity. But it's going up from here to here.
It's all Latina, baby. Okay, let's party, say ole.